Basics of electricity. Electrical circuit. Electric circuit. A simple electrical circuit is a loop containing a source of electrical current and a current consumer linked together by conductor wires. And a switching device is used to close or open the circuit. An electrical circuit must be closed so that the current can pass from the source to consumer and back to the source. Body earth. In a vehicle, the body earth enables the current to return to its source without using an electrical wire. Notice. Electric variable. Electric variable. Three variables define the specifications of the various components in an electric circuit. They are voltage, resistance, current. Above variables can be measured by using multimeter. Voltage. Potential difference between 2 points is known as voltage. A parallel connection can be made using water. Look at these two containers joined by a pipe. The level of water in each container is of equal potential. If the level of water is same and the valve is opened, then the water does not flow. If the water levels are different and the valve is open, then the water flows. It is the same for electricity to carry a current. It is the charge between 2 points in a circuit. The difference in potential between the 2 points is known as voltage. Voltage. Voltage is measured in volts and symbol is V. Resistance. Resistance is a measure of the opposition to current flow in an electrical circuit. Example, in a hydraulic circuit, the water circulates much easier if there is no resistance. If the diameter of the pipeline decreases in between, the water flow will be reduced. Similarly, current will flow easily when there is no resistance in the circuit. If there is any resistance in the electrical circuit, it is difficult for current to flow in the circuit. Resistance. The symbol for resistance is R. Resistance is measured in ohms, whose symbol is ohms. Resistors. A resistor is a component that resists the flow of current when it is built into an electrical circuit. Resistors. There are two different types of resistors. Fixed resistor, variable resistor. Conductors and insulators. Material which allows electricity to flow through the component is called conductor. Example, copper, iron, gold, etc. are good conductor. Material which opposes the electricity to flow through the component is called insulator. Example, rubber, glass, plastic are insulator. By using the material in the circuit, we'll check whether the material is conductor or insulator. If the material is conductors, means the lamp will glow. If the material is insulator, means lamp does not glow. Copper material is a conductor. Rubber material is an insulator. Iron material is a conductor. Glass material is an insulator. Gold material is a conductor. Plastic material is an insulator. Current. Depending on the specification of a circuit, the current flows in a greater or lesser quantity. Current is the rate at which electrons flow past a point in complete electrical circuit. Current. The symbol for current is I. Current is measured in ampere and symbol is A. Protecting circuit, fuse. When the current bypasses its normal route and goes through a circuit with no resistance, a short circuit occurs in the circuit. Example: if the circuit is not protected when two wires touch each other, the wires may burn due to excessive heat. The heat produced is due to the flow of electricity is no longer restricted. A fuse is used to prevent the circuit by protecting the circuit from excessive current. If too much current flows, the fuse will melt before the wire. When the fuse melts, the circuit is open and no current flows. So, the circuit is protected. Ohm's law. Ohm's law. The Ohm's law is one of the basic laws of electricity. Using a formula, it links the variables. Voltage, V, is equal to current, I, multiply resistance, R. If any two of these variables are known, then third variable can be calculated easily. Ohm's law. Here is a graphic representation of the Ohm's law. Voltage, V, is equal to current, I, multiply resistance, R. Resistance, R, is equal to voltage, V, divided by current, I. Current, I, is equal to voltage, V, divided by resistance, R. Series circuit and parallel circuit. There are various types of electrical connections. Series circuit. In series circuit, the current makes a single journey and the current passes through the components one after the other. Parallel circuit. In parallel circuit, the current path is divided into various branches. Current in series circuit. In a series circuit, the current is the same at any point of the circuit. Current in parallel circuit. In a parallel circuit, the total current is the sum of the current passing through all the branches. Voltage in series circuit. In a series circuit, the total voltage is equal to the sum of the individual voltage. Voltage in parallel circuit. In a parallel circuit, the voltage is the same width in each of the branches. Resistors in series circuit. If the two resistors are connected in series, the total resistance is equal to the sum of the individual resistors. Resistance R1 is equal to 2 ohms. Resistance R2 is equal to 8 ohms. Total resistance is equal to sum of individual resistance. Effective resistance R is equal to R12 plus R2, 8. R is equal to 10 ohms. Resistors in parallel circuit. If the two resistors are connected in parallel, the total resistance is lower than the smallest of the individual resistors. Resistance R1 is equal to 2 ohms. Resistance R2 is equal to 8 ohms. Total resistance is not equal to the sum of individual resistance. Power. We have already learned about the variables. Voltage, resistance, current. Variable which defines electrical consumption more precisely is power. Power is related to amount of energy utilized by the component. Symbol for power is P. Unit used to measure power is watt and the symbol is W. In an electrical circuit, to calculate electrical power is equal to voltage multiply current. Graphical representation shows the relationship between power, voltage and current. One of the three values to calculate the power P. The voltage V multiply by the current I. To calculate the voltage V, the power P is divided by the current I. To calculate current I is equal to the power P is divided by the voltage V. Electromagnetism. Electromagnetism. When an electric current passes through a conductive wire, it creates an electric field around the wire, and this phenomenon is known as electromagnetism. Electromagnet. Electromagnet is formed when electricity passes through a coil around a soft iron core. When the current is switched off, the magnetic field disappears. Electromagnetic induction. When a magnet is moving close to the conductive circuit, the circuit generates a current is known as electromagnetic induction. Induction. The purpose of an inductor is to oppose any change in the magnitude of current within a circuit. The electrical property that resists either an increase or decrease in current is known as induction. There are two types of induction. They are self-induction, mutual induction. Self-induction. An induction is created when an electrical current flows in a wire wrapped around a magnetic core. Electromagnetic flux lines develop around the core with formation of a north and south pole at their respective ends. To know the properties of an inductor, we will add a bulb in the circuit. When the switch is closed and the current flows through the circuit, the electromagnetic field forms in the inductor and expands rapidly. Because of this induction properties, the flux lines in the electromagnetic field expands the changing current, and the voltage will resist the current coming from the source. The maximum opposition to current flow occurs at this instant when the switch is closed. Therefore, the bulb will not turn on instantaneously. Once electromagnetic field stops expanding based on the level of changing current, the flux will no longer generate an opposing voltage in the circuit. Mutual induction. Property of a primary coil which affects or changes the current and voltage in a secondary coil is called mutual induction. There are two coils, one is primary coil and another one is secondary coil. When alternating current passed through primary coil, a magnetic flux will be produced in the coil. Due to this magnetic flux, an EMF generated in the secondary coil, and the bulb connects in the secondary coil starts glowing. Electric current. Alternator. The main components of alternator are housing, rotor, stator, rectifier, regulator. Alternator converts mechanical energy to electrical energy with an alternating current. The stator and rotor inside the alternator work as magnets and rotate to generate the alternating current. Then the alternating current is transformed into a direct current that charges the battery. A regulator is used to regulate the charging voltage that the alternator produces. A rectifier is used to convert alternating current into direct current. Electric current. There are two types of electric current: direct current, alternating current. Direct current. Electrical charges always move in the same direction and the graphic representation is straight line. Alternating current. Electrical charges move in reverse direction and the graphical representation is sinusoidal wave. A diode is a semiconductor device that acts as a one-way switch for current. It allows current to flow easily in one direction and restricts current flowing in the opposite direction. To remove the negative part of the signal, diodes are used. The diode is the electrical equivalent of a mechanical valve, and valve allows water to pass in one direction only. Zener diode. The symbol for Zener diode is different from normal diode. In the forward direction, the Zener diode acts like a normal diode. Above a certain voltage, the diode allows current to flow in the opposite direction and does not break down. Light-emitting diode. A light-emitting diode known as an LED works like a standard diode. It lights up when a current passes through it. Photodiode. Photodiode works like a standard diode. When the diode exposed to light, it allows the current to flow in the reverse direction. Rectifier. A rectifier is an electrical device which converts alternating current into direct current by allowing a current to flow in one direction only. Rectifiers are classified into two types. First, half-wave rectifier. Second, full-wave rectifier. Half-wave rectifier. Half-wave rectifiers transform AC voltage to DC voltage, and it uses only one diode for the transformation and allows only one half cycle of an AC voltage waveform to pass and blocking the other half cycle. A high AC voltage is applied to the primary side of the step-down transformer. The obtained secondary low voltage is applied to the diode. The diode is forward biased during the positive half cycle and diode is reverse biased during the negative half cycle. Significant power loss occurs in half-wave rectifier and it is not feasible for any applications that need a steady and smooth operation. Full-wave rectifier. A full-wave rectifier is the one which converts the complete cycle of alternating current into direct current. The full-wave rectifier circuit consists of a center-tapped type, step-down transformer and 4 semiconductor diodes. During the positive half cycle, the diodes D1 and D2 acts as forward biased and diodes D3 and D4 acts as reverse biased. Thus diodes D1 and D2 conducts and current will flow through diodes D1 and D2 and the load resistor is RL. During the negative half cycle, diodes D3 and D4 acts as forward biased and diodes D1 and D2 acts as reversed biased. Thus only diodes D3 and D4 conducts and current will flow through diodes D3 and D4 and the load resistor is RL. Star connection. In a star connection, the three-phase wires are connected to a common point or star point and neutral is taken from this common point. Due to its shape, the star connection is also called as Y connection. Delta connection. In a delta connection, there are only 3 wires for distribution and all the 3 wires are phases. Application of star and delta connection. Star connection. Star-connected transformer is generally used as an auto transformer. Delta connection. Delta-connected transformer is generally used for high voltage transmission. Star-delta connection. Star-delta connected transformer is generally used as a distribution transformer. Single-phase connection. In a single-phase connection, the flow of electricity is through a single conductor. Three-phase connection. In a three-phase connection, consists of 3 separate conductors that are needed for transmitting electricity. Difference between single-phase and three-phase connection. Inverter. An inverter is a device that converts DC power to the AC power used in an electric vehicle motor. The inverter can change the speed at which the motor rotates by adjusting the frequency of the alternating current. IGBT are widely used as a switching device. Inverter is used to control direct current to alternating current to drive the electric motor. Electronic components. PN junction diode. When P-type and N-type silicon are placed in contact with one another forms PN junction diode. N-type material has free electrons and P-type material has holes. PN junction diode in an electrical circuit allows current to flow more easily in one direction than another. In PN junction, the electrons diffuse into the vacant holes in the P material causing a depletion zone. This depletion zone acts like an insulator preventing other free electrons in the N-type silicon from combining with holes in the P-type silicon. Relay. Main function of relay is to control the higher voltage current through lower voltage current. When the control circuit switch is closed, current passes through the coil becomes an electromagnet and attracts the contact in order to close it, and the power circuit is activated. Transistors. The transistor is an electronic component that is widely used in various electronic systems. It has three connections: base, emitter, collector. There are two types of transistors: NPN transistor, PNP transistor. Application of transistors. Transistors makes it possible to control high voltage with low base current. Transistor has two main applications. Transistor can act as switch or relay. Transistor can act as amplifier. MOSFET. MOSFETs used in switching, boosting and power balancing tasks in DC to DC converter, motor control units, power electronic circuits. MOSFET transistor has 3 pins: gate, drain, source. Note: locations may varies depends on the requirement. Consider the gate pin as the valve of the tap, and the water stored in the pipe as drain, and water exits as source. Water flow between the drain and source can be controlled by valve. Similarly, when we apply a voltage to the gate, then the current between the drain and the source can be controlled. IGBT. IGBT are widely used as switching device in the inverter circuit from DC to AC conversion for driving motors. IGBT is the combination of MOSFET and BJT. MOSFET is voltage controlled device. BJT is current controlled device. IGBT can control both voltage and current. Capacitor. A capacitor is a component that can accumulate electrical charges. It consists of two conductive surfaces. The capacitor stores a certain quantity of current. The capacitor charges itself when it is supplied with current. When the supply is cut, the capacitor returns the stored energy. Application of capacitor. Capacitors are used in filters, current stabilizer and timers. Transformers. A transformer is a static power transfer device. Transformers works under the principles of mutual induction. It transfers power from one circuit to another circuit at same frequency. Transformers works only in alternating current. Transformers has two coils: primary coil, secondary coil. Both the coils are wound over a soft iron core. When alternating current passes through the primary coil, magnetic flux is developing in the primary coil, and due to the flux developed in the primary coil, there is a change in flux in the secondary coil based on mutual induction, so an induced EMF is created in the secondary coil. There are two types of transformers. They are step-up transformer, step-down transformer. Step-up transformer. Step-up transformer converts low AC voltage to high AC voltage. The primary windings are made up of thick wire and having less number of turns, and the secondary windings are made of thin wire and having more number of turns. Step-down transformer. Step-down transformer converts high AC voltage to low AC voltage. The primary coils are made up of thin wires with maximum number of turns, and the secondary coils are made up of thick wires and having less number of turns. Buck converter. Buck converter is a DC to DC converter designed to perform the step-down conversion for applied DC input. Buck converter is also called the step-down converter. Buck converter is useful to convert high voltage DC current to low voltage DC current. Boost converter. Boost converter get power input from batteries, solar panels, rectifiers and DC generators. Low input voltage can be converts into high input voltage by using boost converter. Boost converter is a DC to DC converter with an output voltage greater than the source voltage. A boost converter is sometimes called a step-up converter. Signals. Pulse width modulation. Pulse width modulation, or PWM, is a commonly used control technique that generates analog signals from digital devices such as microcontrollers. By using this device, we can control motors, lights and actuators. Pulse width module is used in inverter working principle. Duty cycle. Duty cycle or power cycle is the fraction of one period in which a signal or system is active. Duty cycle is commonly expressed as a percentage or a ratio. A period is the time it takes for a signal to complete an on and off cycle. The duty cycle D is defined as the ratio between the pulse duration or pulse width and the period of a rectangular waveform. Actuators and motors. Solenoid valves. Solenoid valves works under the principle of electromagnetism. When a current passes through the coil of control circuit, the coil magnetic field attracts the core and the core operate the hydraulic or pneumatic circuit. DC electric motor. The main components of DC electric motor are armature or electromagnet, permanent magnet, brush, commutator. when the electric current supply to the brush. The coil becomes an electromagnet placed in the magnetic field of the permanent magnet. The electromagnet moves because of poles attracted by the permanent magnet. Brushless DC motor. The rotor of a BLDC motor has permanent magnet and the stator of BLDC motor has coil arrangement. By apply the DC current to the stator winding, the coil in stator gets energized and become an electromagnet. The operation of the BLDC motor is based on simple force interaction between the permanent magnet and the electromagnet. When coil 1 gets the opposite poles on the rotor and stator attracts each other. When rotor gets close to coil 1, coil 2 gets energized. When rotor gets close to coil 2, coil 3 gets energized. After that, coil 1 gets energized with the opposite polarity. This process gets repeated and rotor continues to rotate. Induction motor. In an induction motor, there are two major components are there. First, stator. Second, rotor. Motor control unit send the alternating current to the stator winding. This creates a rotating magnetic field and the fluctuating field interacts with the rotor to create electromotive forces which generates current in the rotor. Due to the interaction between these induced currents and the EMF, the rotor starts rotating. Interior permanent magnet synchronous motor. Permanent magnet motor works based on attraction between two magnetic fields, so they produce a good starting torque when you operate them using a controller and they do not experience energy loss in the rotor. An efficient permanent magnet rotor can be made by placing permanent magnets around a solid iron cylinder by replacing the traditional rotor which is used in induction motor. By placing 4 permanent magnets on solid iron cylinder, it helps to produce combined magnetic field around a solid iron cylinder. There is some interaction between the rotating magnetic field and the combined magnetic field, and force interaction between two magnetic field is simple by observing how the south and north poles interact with each other. Fix the rotor in stator winding and hide the stator winding and keep only the north and south poles. Observe the force interaction between different poles at this angle and rotating magnetic field will create a torque on the rotor. By rotating the RMF by 45 degrees, rotor will experiences maximum torque because of the attractive and repulsive forces are almost tangential to the rotor and they produce torque in the same direction. We can modify this design so that it will work efficiently. By using the following concept, vehicle can be drive at high speeds without generates back EMF. For high speed operation, we are using reluctance method. Reluctance property is the ability to oppose magnetic fields. In rotor, when slots are cut in the iron, rotor have high reluctant state. Turn the rotor by 45 degrees. Very low reluctance will occurs and rotor always tends to attain a low reluctant state. Therefore, the rotor will rotate along with magnetic field. Rotor always have low reluctant state, so the rotor speed will be same as RMF speed. The torque produced by this phenomenon is known as reluctance torque, and such motors are called synchronous reluctance motors. Synchronous reluctance motor are good for high-speed motor. No back EMF is generated while driving in high speed. Permanent magnet motor are good for normal speed motor. Back EMF will generate while driving in high speed. Combination of permanent magnet in synchronous reluctance motor will work more efficient at any speed. The magnet in motor further reduces the magnet's effect on stator winding and thus reduces back EMF. This design is the interior permanent magnet synchronous motor. The relative permeability of the magnets is almost the same as that of the air. So, they will oppose the field to passes through the air and generates the reluctance torque. In permanent magnets, when we increase the motor speed, back EMF will be generated at stator coils. To rectify the back EMF issue, align the rotating magnetic field opposite to the permanent magnetic field. RMF weakens or almost cancels the permanent magnet field. Generation of back EMF will be controlled by using this method.